Nowadays, as we are moving towards the carbon neutrality based on the PCA roadmap till 2050, it's very important to apply new technologies and new science into cement industry as well. And part of my job is to find different solutions. Either it's the optimization of the cement blends based on different numerical methods like machine learning, AI techniques, or even it's based on the chemistry. So I think it's very important to apply new knowledges out there into cement industry and cement production in order to reach that goal of zero carbon in the cement industry.
I'm very excited to get to 2050 and see what we can make. I think it's definitely going to be reliant on blended cements and also carbon capture, and possibly figuring out what to do with that carbon once we capture it. Yeah, I think once we understand blended cements better, I think we're going to be able to make something that's much more than just 25–40% replace cementitious.
Concrete structures, every day they absorb CO2. When I'm driving back home, I see all these structures and how they absorb CO2 every day. This is fascinating. And we really need to quantify this. It's a big, the chemistry, the stoichiometry is known. It's really well known out there. But when we scale it up to the whole infrastructure out there, it's a huge number.
One of the things that we do at this site is we actually use steel slag. Steel slag is a byproduct of the steel manufacturing industry. So you can take something that's made by another industry that actually would be designated for a landfill. We can use it as a raw material. It's already basically been calcined. So instead of having CO2 go up the stack, it gives you the same benefit as you would of putting raw material through the kiln, but with no CO2 generation whatsoever. Because we also get the benefit of the iron, the magnesium, some other key ingredients that come along for the ride with the slag. So it is a win-win.
You know, I have a son and I want him to be able to be around and enjoy the scenery of California for a long time. And as project engineering, we're constantly working on projects to reduce our emissions and get to that carbon neutral goal. We're working on adding alt fuel systems to burn waste fuels and engineered fuels to reduce our carbon footprint and reduce our electricity usage and reduce our emissions through our kilns. So as a project engineer, that's the challenge, is I have to come up with innovative ideas to reach that goal. And being, you know, a young engineer in the industry, I'm gonna be here when that 2050 hits. So I've got to look at that long term, is that's what I'm doing here.
I think where the U.S. is headed is kind of where Europe's been for several decades. You take cement, you add higher percentages of limestone. There's actually some advantages from a longevity standpoint of the concrete, and you reduce the CO2 footprint per ton of cement produced. That's really not something that's new to the industry. It's just more new in the United States, and obviously a place that we're heading as an industry here in this country. CalPortland has its own fleet of approximately 20 compressed natural gas trucks. So we talked about earlier the need to reduce carbon footprint as a company, as a plant site. Well, it's pretty awesome to have trucks that by design help in that regard too. So once again, a win-win. We try to reduce the carbon footprint with the cement we make, and then we try to reduce the carbon footprint when we deliver it to the marketplace.